Welcome everybody to this prep-in session for the AI technical phone screen. So the goal of today's session is to prepare you for the technical phone interview, which represents the first technical component of the interview process for our AI and machine learning engineering positions here at LinkedIn. So let me start by telling you a little bit about who I am. So my name is Tyler. I worked at LinkedIn for about 2.5 years now on a team called the Data Standardization or the Standardization AI team. We solve this problem of, for example, one person might come onto LinkedIn and say, I am a software engineer. And somebody else might come onto LinkedIn and say, I am a developer. And someone else might say, I'm a programmer, right? So here are 3 different people that have essentially the same job, but they describe that job using different natural language strings. And somehow LinkedIn needs to understand that they do essentially the same economic activity. This is what we call the standardization problem, and we have to solve it not just for job titles, but also for degrees, fields of study, schools, skills, company names, and so on. So that's what I do. I'm also joined today by Ronnie, so I'll let him give a quick intro as well.
Hey everyone, excited to talk with you today. I also work on the data standardization team with Tyler, and then also worked on ads here before for the last approximately 3 years.
Great, so we're going to be working together to run this session and hopefully tell you everything you need to know in order to do well on the technical phone interview. So the first part of the phone screen is what we call the data coding portion of the interview. This part of the interview can take one of 2 different forms. So either this is kind of a classic LeetCode style algorithmic coding question, the kind of question that you would normally see in a generalist software engineering interview, for example, except with a possible data emphasis. So a classic coding question, except that we might lean a little bit more heavily on the kinds of concepts that you would be expected to know for a machine learning or AI position at LinkedIn. So, you can think like basics of probability or matrix and vector algebra and so on. But again, the focus here in this type of question is really on writing an algorithmic solution to some kind of technical question in a language of your choice. So that's one possible format for this part of the interview. The other possible format basically takes the form, code up a machine learning algorithm. Here's a popular machine learning algorithm that we expect everyone to be familiar with, everyone who's interviewing for this role to be familiar with, at least at a high level. Can you code up a simplified implementation of this machine learning algorithm? So these are sort of the 2 possible flavors for this part of the interview. We have some general advice for how to succeed on the data coding portion of the interview. So our first piece of advice is to not start coding right away, even if that's what your initial temptation is. So instead of directly writing code as soon as you hear what the question is, we recommend that you instead ask clarifying questions, state any assumptions that you think are necessary to make in order to solve the problem, and maybe begin to outline a solution verbally or in pseudocode at a very high level without actually starting work on an implementation in the actual coding language that you're going to be using, right? So a mistake that we see lots of candidates make is to start writing code and then realize halfway through that they're actually answering a different question, a question other than the one that was actually asked. So it's really important that you make sure you understand what the question is and also start to outline what your solution approach is even before you actually write any code at all. Once you have a plan in mind, all of the things that normally apply when you're writing code outside the context of an interview still apply within the interview setting. So you want to think about what kinds of relevant data structures and algorithms are given the problem at hand. You want to check edge cases and corner cases other than the prototypical case that you might have in mind. It's always a good idea to walk through test cases. So in our collaborative code editor, we use CoderPad. We actually disable code execution. So you won't be required to or even able to run code live during the interview. So instead of actually running code, it's good for you to kind of like simulate the execution of code through simple test cases and walk through line by line and say, okay, this is what my solution is doing at this point on this simple test case. And of course, it's always good to write clean and readable code, the kind of code that you would be happy to read if somebody else had written it. One thing that is different in the interview setting compared to when you're just coding on your own is that there's someone who's listening to you, right? The interviewer is trying to understand your thought process and your problem-solving approach. So it's important to keep communicating throughout this portion of the interview. You don't necessarily have to emit a continuous stream of speech as you're writing up your solution, but as much as possible, remember to kind of pause at key points and say, okay, this is what I've just written. This is what I'm going to do next. This is where I am in my high level approach to the problem. So if this is something that feels unnatural to you because you don't talk aloud to yourself when coding on your own, it's a good idea to at least get some practice with being able to both write code and solve a problem while explaining your thought process to someone who's listening in. And finally, once you have an initial solution down, consider how you might optimize the solution. So in terms of performance, you might want to think about, are there ways that we can improve the time or space complexity of our solution? Is our solution as efficient as it possibly can be? But even beyond just performance considerations, there are other ways that you can think about improving your solution, right? So one major way is to improve the quality of the code that you've written. Maybe you write down an initial solution, and then you realize that maybe it can be refactored or modularized in some kind of way, that maybe you can break out a certain part of the code into a helper function, for example, right? So it's important to really take a holistic approach towards thinking about the quality of your solution, not just in terms of performance, which is obviously important, but also in terms of readability and general code hygiene. So this is our advice at kind of an abstract level, but to really make this concrete, we want to actually illustrate what an example coding question would look like, so you have a sense for the pacing and the style of this part of the interview. So let me switch over to our collaborative code editor, and I'll have Ronnie join me to play the role of the interviewer, and I'll play the role of the candidate. So yes, I'll turn it over to Ronnie.
Sounds good. So, hey, Tyler, super excited to meet with you today. And then generally spend the first 5-6 minutes learning about super awesome things you've done in the past. For example, your work in data standardization and some of the models and hard challenges that you tackled there. And then for kind of the format of the interview, as we just mentioned, first 5-10 minutes we spent on intros. We'll then spend the next approximately 20-25 minutes on a coding question that we're doing right now. And then the 20-25 minutes after that on some kind of short answer questions or really digging more into your data mining background over there, kind of conceptual and domain questions. And then lastly, we'll have 5-10 minutes for wrap up and any other questions we can help to answer around how awesome the culture is here at LinkedIn. So with that as a preset, as a preface, we can now jump into the coding question. So today we're going to be looking at a coding question that really relies upon this concept of sampling. And sampling is really key to a lot of the different things here we do at LinkedIn. For example, when you go to your LinkedIn page on feed every day, there's thousands of possible posts that we could show you from many different connections, but we have to sample the ones that we think are most relevant and most useful to you at a current time. So it's definitely something that we use across many different teams and actively impacts the product day to day. So I'm going to copy in the actual question text, and then we can kind of go through it in case there's any ambiguity there. So let me quickly copy it in. And then what language do you prefer to use?
I think I'm going to stick with Python for this.
Okay, cool. Sounds good.
All right. So let me just read what we have here. So it says, given a list of pairs of integers, where each pair represents an integer range, and none of the ranges overlap, sample uniformly at random from the union of these ranges. So for example, given a list with inclusive ranges, 2, 3, and 14, 16, you should return one of the 5 integers, 2, 3, 14, 15, or 16, each with equal probability. For example, the output here could be a 3 with probability 1/5, given this list above. Furthermore, we can assume that we only have access to the function randint ab, which generates a random number x between a and b, where a is less than or equal to x and x is strictly less than b. Okay, and so from this last part of the problem description, I'm guessing this means that I can't do something like from random import, whatever, and then use those library methods for random number generation. Is that correct?
Yeah, exactly. I would say really you have access to most of the Python standard library, most of the numerical libraries, but we just want to make sure that we're able to kind of address how you would tackle this problem rather than use perhaps a solution provided by the library.
Okay, makes sense. All right, let me put on my coding goggles. So let's see, the first thing that I'm thinking of here is maybe to decompose this problem into 2 different subproblems and take a 2-step approach. So the first step that I'm thinking of is to use randint to select a random range from the list of ranges. So in this example, I would select either the range 2, 3 or 14, 16. And then once I've pinned down a particular range, I use randint a second time to select a random integer from this range that I chose in the first step of my process. So what do you think about that as like a high-level description of a possible solution here?
Okay, so random select the random range first to ranges and then an integer. So if I kind of work this out, so to use random select a random range, so we can select. So what would that call be? Like rand and 0 to len of the ranges plus 1. So then we would get like 0, 1 there.
Yeah, something like that, right?
Okay, cool. So it generates, let's say 1. So then inside of that, we would have random then again, and then we would get like the 14. So it seems like the probability there would be 1/2 on the first, and then 14, 15, 16, 1/3 there. But ideally, since there's, so that'd give us like 1/6. But ideally, since there's 5 numbers that we can see above, if this was uniform, we would want it to be 1/5 though. So it seems like we might have a bit of a disconnect there.
Okay, I see, right. So 1/2 is the probability of selecting one of these 2 ranges, or it's the probability of selecting the second range in particular. And then 1/3 is the conditional probability of selecting one of these 3 integers, given that we've chosen that range. But yes, you're right. Since there are 5 integers total, it's strange that these 3 integers have probability 1/6. And if I do a similar calculation for the first range, I would find that the probability of selecting an integer from 2, 3 would be 1/2 times 1/2 again, so 1/4. So okay, so in other words, we're biased in favor of selecting integers from the smaller range. And okay, maybe I can even think of an extreme example here, like if instead of 14, 16, if my ranges were like 2, 3, and then like 100 to 1,000 or something, right? The integers in this second range would all have much lower probability of being selected. Okay, so there's a problem with this solution because it's biased against the larger ranges. And it doesn't return all of the integers in the union with equal probability. Okay, then let me maybe rethink my approach here. Well, looking at the example again, if we're trying to return one of these 5 integers in this example with equal probability, maybe the simplest thing to do is actually to explicitly construct this list consisting of all the integers in the union of the ranges, and then to make a single call to randint to generate a random index into that list and just return whatever integers at that index in the list. What do you think about that approach instead?
Sorry, didn't fully understand that. You would generate another one to get it into that list.
Sorry, so yeah, I would explicitly construct the list representing the union of the ranges, and then I would make a single call to randint to generate an index into that list, and then just return whatever element is at that index in the in this union list.
Makes sense. So you'd explicitly construct the union first. Yeah, I think that makes sense. Definitely is a good first step and makes it really explicit that we're getting the end results kind of in sampling uniformly like we expect. Right.
Yeah, I guess it's easier to think about correctness in that approach. Okay, so then let me start writing some code to actually do this. So let's call this function get random int from ranges. It takes in a list of ranges. So that will be like a list of tuples of integers. And it will return a single integer. So yeah, let me know if you see any issues with the signature here, but otherwise I'll get right into the implementation. So the first thing I want to do, I think, is to build up this list of all the integers in the union of ranges. So if I iterate through each range, so if I go through each A, B pair in my ranges, and then for each range, if I just iterate through all the integers in that range, so now I can use the Python built-in range and go from A to, I think I want to go to B plus 1, because these ranges are inclusive, but Python's range function is right endpoint exclusive. So I will just iterate through all the integers in the union of the ranges, and then if I just collect that into a list, I think that will give me exactly what I want. And then if I create this random index by making a call to randint, let's see, I want to go from 0 up until the length of all ints. And I don't think I need a +1 there because randint is already right endpoint exclusive, which is what I want. And then I can just return the integer in all ints at this random index. And I think that will be the uniform random sample that I'm looking for. So just to illustrate what's going on here, this all ints list will be precisely this list in the example. Random index can be anything from 0 to 4. Let's suppose that it's a 2 or a 1. And then in this final step, we'll return the 3 corresponding to the index 1 in my all ints list. So does that make sense to you?
Constructing it here. Okay, cool. Sounds good to me. And then just so I understand further, could we perhaps discuss kind of what the complexities here would look like for the different parts of the algorithm?
Okay, sure. So all of the work really is being done on line 44 here, where I'm actually generating the list of all the integers. And in terms of both time and space, this line will be linear in the number of integers in the union of ranges. So it will be O of n, where n is the number of ints in the union of ranges, and same for space. Space will also be O of n, and for example, in this example, n would be equal to 5 because there are 5 different integers in this union of ranges.
Okay. So it makes sense to me. I'm kind of interested here on time and space here, where you notice the union of ranges. Because over here, as we saw, this is kind of nice, that it's a sparse representation of it. So if we had something like, let's say a really popular LinkedIn member, so let's say we're sampling his posts, and we had something like 2, 3 initially, and then we had 4, and then like 1e to like the 6. Lots of different posts he could see. He's connected to literally all the people. It seems like we'd use a lot of memory there.
Okay,
So
yeah.
I'm kind of concerned for this algorithm kind of to scale up to all of our members.
Okay, so yeah, I think if I understand what you're saying, if we have a range that's particularly large, that's wide, right? Even though the representation of that range is compact, right? We just have to specify the left and the right endpoints. In our solution where we're sampling from the union of the ranges, we have to explicitly construct this list consisting of every integer in the union of the ranges. And so we end up kind of like, we end up with, you know, a large representation, right? A representation that takes a lot of memory and that potentially takes a lot of time to construct as well. Okay, so if I understand what you're kind of suggesting here, maybe there's a way that we can kind of maintain this sparse and compact representation where we only have to kind of worry about the endpoints of the ranges and still be able to sample from those ranges without actually, you know, generating all of the integers in those ranges explicitly. Is that the idea here?
Exactly. Trying to look at how we could maybe do some trade-offs in our complexities there to exactly do that.
Okay. So yeah, I guess if I look back at my initial idea with this two-step approach, that approach was wrong. It was incorrect in the sense that it didn't actually generate a uniform random sample. But one redeeming quality about that approach is that it didn't require any explicit construction of these lists, right? These lists of integers. It just involved 2 constant time calls to rand int. So maybe the hope is that we can do something similar, except in a way that actually returns a uniform random sample. That, in other words, that's actually correct. So if I think about the idea that I have here in code, what we're doing is we're building up this list, and we're associating with each element in this list an index. And then we're generating, we're picking one of those indices at random and then returning the integer in the list, the union list corresponding to that index. But maybe there's a way for me to kind of do some clever arithmetic with the left endpoints and the index that I generate in such a way that I don't actually have to explicitly construct this list. So for example, let's suppose the random index that I generate is a 3, meaning that I want to return 15, the integer in this union list, at index 3. So one way I can return 15 is to explicitly construct this list and then index into it, right? But I think another way that I can return the 15 is to use the fact that I know that the first range the first range, in other words, the 2, 3 range, has size 2. It has 2 integers in that range, right? And so using the fact that the first range has size 2 and that my random index is 3, I can generate an offset into the next range, right? So I can say the offset into my next range should be the random index minus the number of integers that I've already seen in all of the ranges up until this point. In this case, just 2, because I've only seen one range of size 2. And then, okay, so that offset would be equal to 1. 3 minus 2 is 1. So that basically means that I need to look, one integer into my next range and return whatever that integer is. So in other words, I can add 14, the left endpoint of the next range, to this offset, which is 1, which will give me 15, which is precisely the integer that I want to return. So in other ways, there's like this way of doing this kind of clever arithmetic with the left endpoints and these offsets that I'm kind of continuously updating as I iterate through the ranges in my list of ranges. And I can add the offset to the left endpoint to return an integer in constant time without ever having to actually explicitly construct this list consisting of the union of integers. So yeah, maybe I was a little bit sketchy in my approach here, but at a high level, how does this sound to you?
And just to clarify here, when you're doing the 14 plus 1, that's actually indexing into the index of 14 plus 1 offset, right?
Yes.
Or are you doing actual addition? Both should work. Okay, cool. It makes sense. And then to calculate sort of your initial, where you can sample from, how would you get the possible length of the overall set, or the overall size of this over here at the top?
Right. How would I know, in other words, to go from 0 to 4 if I'm not taking like the length of a union list? Yeah, so I can also just do arithmetic here and just, compute the length of each range. The length of the first range is 2, and that's like 3 minus 2 plus 1. And the length of the second range, I guess in our simpler example, the 14, 16 range, that's 3, which is 16 minus 14 plus 1 again, right? So I don't actually have to create the list of all the integers and then get the size of that list to know the bounds on my index. Instead, I can just iterate through all of the ranges and do some arithmetic there, some constant time arithmetic.
Okay, sounds good. It sounds like we would both be saving in the amount of computation a bit there, in that we're only doing now 2 additions per element in the overall list, rather than the elements inside it having to expand that out, in addition to also saving space here, since we don't actually need to write out any new lists. So we would be able to use a constant time space here.
Yes.
Sounds good.
Yeah, we can use constant time space, and then time complexity would be linear, not in the number of integers in the union of the ranges, but linear in the number of ranges itself. So we're really taking advantage of this kind of compact representation of those ranges. And we can deal with ranges that are arbitrarily large as long as we have the ability to do, big int arithmetic or something.
Sounds awesome.
Yeah. So actually, let's step out of demo mode at this point. So, in the course of the normal interview, we would actually go ahead and implement this improved solution and analyze it and so on. But in the interest of time, we'll actually end here. And maybe it's a good exercise for all of you watching at home to go ahead and implement this on your own and verify that you can get a working solution here. But I think at this point, the style of this part of the interview is clear. So we're going to move on. The next part of the interview is what we call the data mining, or the data mining product design part of the interview. This part of the interview can also take one of 2 different possible forms. So either we might ask you a collection of conceptual questions in machine learning, artificial intelligence, data mining, statistics, probability, etc. Right? All of these foundational fields that we rely on as machine learning engineers. Or alternatively, we might ask you to imagine that a product manager has asked you to design a new AI-powered product for the LinkedIn app, right? So you can imagine what kinds of features on LinkedIn might be powered by artificial intelligence or machine learning. And then your job in this part of the interview is to imagine that that feature doesn't exist today and that you're tasked with coming up with the design for how that feature would be implemented for some kind of potential future release, right? So these are the two possible ways that we're trying to probe your kind of foundational knowledge in concepts from machine learning, data mining, and so on, to make sure that you have the relevant background, not just to do software engineering, but to do machine learning software engineering. So we have a set of general guidelines for this part of the interview as well. If it's been a while since you've revisited your conceptual foundations in machine learning and AI, then it's a good idea to go back and kind of remind yourself, okay, like, you know, what is bias variance? What is overfitting versus underfitting? What are all of the different types of common model classes and their trade-offs and so on, right? And as a rough guide to the kinds of material that you should be focusing on as you go back and review for this part of the interview, you can kind of think of like all of the material from an introductory machine learning class as being fair game, perhaps minus some of the more theoretical or less applied parts of a typical intro machine learning syllabus. So a lot of intro machine learning classes will spend some amount of time on support vector machines, for example. And while SVMs are interesting, they're just not that widely used, you know, these days in applied machine learning projects, at least not at LinkedIn. So you can probably avoid you know, studying up on all of the details of SVMs, for example. Similarly, for a topic like computational learning theory, which again is an interesting topic, but probably too theoretical for the kinds of work, for the kinds of projects that we do here at LinkedIn in terms of building machine learning powered products. Okay, once you're at the actual interview stage, when you're in the data mining or data mining product design interview, as in the coding part of the interview, start by clarifying and making sure that you actually understand the question being asked. In this part of the interview especially, questions will often take a vaguer or more ambiguous form than the questions we asked in the data coding section. So if the question is asked in an imprecise form, make the question precise. Make sure you understand, you know, what are we actually trying to build, or, you know, what is the interviewer actually asking, if they're asking a conceptual question, for example. This part of the interview is probably even more verbal and involves more communication than the data coding part of the interview. So it's important to keep talking. You'll still have access to the coder pad, even though you won't be writing any code in this part of the interview. And we recommend that you use the coder pad to jot down notes and key points, and, you know, just stay aligned with your interview and have some shared context that both of you can look at. It's a good idea to start at a high level and be prepared to go deeper. So you don't want to spend all of your time on, you know, just one particular part of the machine learning lifecycle, for example. Like, don't spend all of your time talking in depth about the data sets that you'll be using and what kinds of approaches you might take to data cleaning. Instead, keep the interview going, and your interviewer will push you to go deeper on certain points if they think it's, you know, appropriate to the interview setting, right? So stay at a high level, but be prepared to dive deep at any part of the machine learning design cycle. And finally, one anti-pattern that I've seen before is people, you know, claiming to know something that they actually don't, right? So it's very easy for the interviewer to figure out if you're making a false claim about, you know, the knowledge that you possess. So if, you know, your memory is failing you, or if you can't remember the details of a particular concept or model or something, it's okay to acknowledge gaps in your knowledge, right? We're not expecting you to have encyclopedic knowledge of anything that could possibly, everything that could possibly be relevant to a machine learning project. So if you find that you're being asked about something that you're not super familiar with, it's okay to say, oh, I don't remember the details. This is what I do know. And this is maybe what I would, Google or try and look up if I had to learn more about this. And then finally, once you have a basic solution down or the skeleton of a solution, if it makes sense to do so, verify that your solution is actually solving the problem at hand. And if you're answering a design problem, then it's always a good idea to contextualize your solution in the background and in the context of the givens of the design problem, right? So if you've talked for a while about the details of a particular model, it's always good to connect those details back to the high-level problem that you're actually being asked to solve. Okay, so those are some general principles and recommendations that we have for this part of the interview. We won't have time to do a full demo like we did for the data coding part of this interview, but just to give you an idea of the flavor of this part of the interview, we have this example. So the Challenger disaster was a NASA space shuttle launch in the 80s that went catastrophically wrong. And in the post-mortem of this disaster, it was realized that basically the failure that the space shuttle experienced could have been predicted given the data that was available at the time. So the failure involved these faulty O-rings, which is a part of the space shuttle. And it turns out that there was actually data available at the time of the launch that should have allowed the key decision makers to realize that this particular shuttle flight was at risk of experiencing some kind of catastrophic failure. So for the purposes of our interview, even though this isn't a LinkedIn specific example, we're really just interested in interested in this case study as a prediction task, right? How would you be able to predict that any particular shuttle launch is at risk given data that we have about past shuttle launches? So to be a little bit more precise here, suppose we have a data set describing 23 previous shuttle flights, and this data set has the following columns in it: the number of O-rings, the number of those O-rings that experienced thermal distress, the launch temperatures in degrees Fahrenheit, the leak check pressure in pounds per square inch, and the launch number, which increments in sequence. So given this data set, how can we predict whether O-rings are at risk given the launch conditions? So this is the task, right? This is the scenario that an interviewer might pose to you. And now our task is to explain, okay, what is our thought process in approaching this machine learning prediction problem? So some things that we might be thinking about is, okay, what is actually the prediction task, right? We want to know whether O-rings are at risk given the launch conditions. So does that mean that this is a binary classification problem where we want to say, okay, is at least one O-ring at risk given launch? And then that can be a yes or no question. Or do we want to treat this as a regression problem where we want to say how many O-rings are at risk in a particular launch given the launch conditions, right? So that's something that we would want to clarify, right? What is the nature of the prediction task? And then depending on what makes sense in the context of the problem, that will influence, the rest of our approach to solving this prediction task, right? So let's suppose that we're interested in binary classification. In other words, that one O-ring failing is enough to abort a launch. In that case, we would use this column here, the number of O-rings experiencing thermal distress, and code that as a binary label, right? So if at least one O-ring experiences thermal distress, that's a 1, otherwise it's a 0. And now we have a binary classification problem at hand. Okay, next we can start to think about features, right? the number of O-rings, for example, right? Well, this is a column that might be constant or it might change from one launch to another, right? For example, if the architecture of the space shuttle isn't changing from one launch to the next, then presumably the number of O-rings is staying the same across all the different launches. In that case, we have a constant column and we can probably just discard it as a feature, right? It provides no predictive value for our task at hand, right? On the other hand, if it was changing, then we might need to rethink how we approach this problem, right? We can also think about, whether launch temperature is relevant, whether leak check pressure is relevant, what leak check pressure even means, right? So, I'm not a rocket scientist, so I don't actually know whether these features are relevant or not to predicting O-ring failure, but these are the kinds of questions that we would want to ask, right, with respect to what features we use. Okay, then we can start to think about like what kind of model we want to use to actually solve this prediction problem, right? Given that we only have 23 rows in our data set, our data set only consists of 23 launches, we probably want to do something as simple as possible, right? A linear classifier, for example, something like logistic regression. So it's important to consider like the size of the data set, right? And if we only have 23 previous shuttle flights, then splitting into training and test sets becomes difficult, right? We don't have the luxury of having an abundance of data here. So we really need to be judicious in terms of allocating our data between training and validation and test sets and so on, right? In particular, if we use like a classic like 80-20 or 70-30 split or something along those lines, we might only have a handful of rows in our test set, right? Which isn't something to get a statistically meaningful performance metric out of, right? Speaking of performance metrics, we want to think about, all right, what kinds of things do we want to use to evaluate the quality of the model that we train, right? If we're thinking about this as a binary classification problem, then we should think about whether false positives or false negatives are more costly, right? Is it worse to predict that an O-ring will fail even though it doesn't? Or the opposite, is it worse to predict that an O-ring won't fail and then have it actually fail at launch time, right? So depending on which kind of mistake we think is more costly, we might want to choose a evaluation metric that allows us to gain insight into whether we have too many false positives or too many false negatives, right? Okay, so that was kind of a lot of different things to think about really quickly, right? Again, we're not doing a real demo here. These are just the kinds of things that you would want to be thinking in collaboration with your interviewer, given a design problem that takes this form. And then your interviewer will, slow you down, will ask to go deeper, will ask you things like, okay, like what is logistic regression, or what kinds of metrics would you use? What are the definitions of those metrics, right? Things like that to actually kind of dive deep on the details here. So that's something that we didn't do here, but hopefully you have an idea of the flavor of this part of the interview and what kinds of things are relevant to think about here. Okay, so that's the data mining / data mining product design part of the interview. And that's really the entire technical content of the AI engineering phone screen. So having covered both of those two major parts of the interview, the data coding part and the data mining part, in the last couple minutes of this session, I'm just going to go back and forth with Ronnie on some questions that we get asked frequently, that we've been asked frequently in past iterations of this webinar session when we've run it live in the past. So, Ronnie, I'm wondering, how many coding problems do we typically need to solve in the data coding part of this interview?
So generally, like we saw today, there's one coding problem, and sometimes we'll have follow-ups to dig deeper into complexity or how we can optimize the solution.
Cool. And just to clarify, will we actually need to compile and run the code that we write?
No, the interview process at LinkedIn is really focused on your process and sort of thinking when you're going through the problem rather than can you do this like exact minutiae of syntax and make it compile.
Okay, cool. Yeah, that's good because I often forget, like the names of library methods and stuff like that. So it's nice to know that we won't actually be executing code live. Okay, and then, earlier it was mentioned that the data coding part of the interview can take two forms. Either it's more of an algorithmic coding question, or it's more like implement this machine learning algorithm. So for the latter type of question, will we be given like the machine learning algorithm in pseudocode, and then it's our job to like translate that pseudocode into Python and NumPy and so on? Like what exactly is the format of that part of the interview?
I'd say it kind of looks like, oh, hey, Tyler, we use independent components analysis quite a lot at LinkedIn. What does that sort of mean to you? What does that kind of look like algorithm-wise? And then could you code out a rough demo of what you just described? And
Okay.
a few things to really note there is, would really, really strongly suggest using numerical and matrix libraries. If you have to start kind of coding the vector portions, you probably wouldn't have that much time to actually finish. So really being familiar kind of with how to do math and vector and tensor operations in your library of choice would give you a leg up there.
Okay. So if I'm using Python, for example, it might be a good idea to make sure I'm familiar with the NumPy API.
100%.
Okay, cool. And if I have a particular specialized background, for example, I've done a lot of work in computer vision, maybe. Will the data mining part of the interview focus on my particular area of expertise, or will it be more like general machine learning concepts?
I'd say one benefit of really the LinkedIn process here is it allows you to and the interviewer to have a conversation, especially as it leans towards your strengths. So in that initial sort of 10 minutes when you intro, hey, this is the sorts of problems I work on, that also can then lead to when you do your data mining design question, like in the second portion of the interview we covered, and you can use that sort of expertise, as well as in some of the other questions that you get asked. So an example here would be, if you get asked what are some sort of different metrics that use an evaluation, you can say, hey, in previous work I've done, I've used these sorts of things, which is really common in CV. So in this way, we're both able to ask a general sort of question panel for ML to ensure that you have a breadth of knowledge, but also still allow you to highlight your strengths in past work and past specialty. Sorry.
Okay, cool. That makes sense to me. Is there anywhere that I can go, like any online resource that I can use to find machine learning specific practice questions, right? I know that LeetCode exists for classic algorithmic coding questions. Is there anything that I can do to prepare for machine learning specific questions?
Ooh, I think the suggestion you gave earlier about really reviewing previous course material, exams, would be good there. I think there's also a few like intro to ML interviews, books that I've seen popping up. Do you have recommendations here?
I don't know of anything kind of like as, popular as LeetCode or, anything that's freely available along those lines. Right. It's like kind of a more niche, it's more of a niche domain, right? So maybe a year from now or something, we'll have a different answer. But at least as of today, right, for the coding part of the interview, it's a good idea to just review, algorithms and data structures in the way that you would for a typical coding question. And then I think, yes, for the data mining part of the interview, just review some of those conceptual foundations, the kinds of things that you would see in an intro machine learning syllabus, for example.
Sounds good. And now let me flip the questions. So, hey, Tyler, do you think we'll be expected to answer questions about deep learning or neural networks?
So this goes a little bit back to what we said about, if you have specialized expertise, will the interview be about that expertise, or will it be about, machine learning in general, right? So again, I mean, in 2022, right, it's good to know about deep learning, right? It's often the way to get state-of-the-art results across a wide variety of different application domains. So yes, you should probably know about neural networks. You should probably know about deep learning techniques, right? That said, I would be surprised if the data mining part of the interview was like focused exclusively on deep learning, right? So know about deep learning, and then if you have special expertise in a particular area of deep learning, you can mention that and push the interview in that direction. But otherwise, no, you won't. There won't be like a deep learning part of the interview.
Sounds good. And then in my experience with kind of previous interviews at different companies, the interviews kind of varied sometimes on how deep they actually want to go into the sort of details about ML. So some have been satisfied with surface level responses, like this is how this happens. And then some really want to dig into it. For example, how do you do the Bayesian inference for this step of the algorithm? What can I kind of expect in the interview here?
Okay, yeah. So like we said earlier, in general, for like the design and conceptual questions that we ask, we want you to kind of stay at a high level and cover all of the pieces, right, that are involved in designing a machine learning powered product, for example, and to be prepared to go deeper. Now, I think this question is asking how deep and which areas can I expect to be pushed deeply on, right? So I think the rule here is that if you claim special expertise in a particular machine learning subfield, right? For example, computer vision or natural language processing or reinforcement learning or something, right? Then you should be prepared to go deep in those areas, right? At the same time, you should also be prepared to go deep in any of the kind of common core foundational parts of machine learning, right? So anyone, no matter what your expertise is, anyone who's doing machine learning should understand like what overfitting and underfitting are and how you would distinguish between those two possible cases when training a model and what you can do in either case, right? So these are the areas where you should be prepared to go deeper and to like dive into the details. But if you don't claim that you have expertise in a particular machine learning subdomain, then it probably won't be an issue if you can't explain all the details there. So if someone asks you how you would do Bayesian inference to infer the parameters of some kind of machine learning model and like find posterior distributions or whatever, if that's not an area of machine learning that you're familiar with or that you claim to be familiar with, then I think it's fine to just say, oh, I have a vague understanding of what that means, but I can't really say anything, super precise. So that's totally fine.
Makes sense. And then I noticed there's no section on system design here. Is that kind of specific to the SWE role versus the SWE ML engineer kind of thing here?
So if by system design, you mean like, drawing boxes, illustrating the backend architecture for some kind of feature, then yes, there's no system design part of the interview. But like the machine learning, data mining, product design part of the interview is a design part of the interview, right? You need to think about, okay, like what data sets are relevant to solve this problem? What model would I use? What kinds of evaluation metrics am I trying to optimize? What makes sense given the product requirements, right? So these are all design questions in the sense that they're at a high level. We're not actually asking you to write code, but we're asking you to think about narrowing the design space, making trade-offs, coming up with a solution that's appropriate to the context that you're given. So there is a design part of the interview. It's just not like a back-end architecture design question.
Makes sense. And then what sort of split on statistics versus ML should I expect?
I mean, maybe we need to define what those terms are to answer this question. But if by statistics you mean like p-values and confidence intervals, or Bayesian statistics and so on, then definitely more on the machine learning side, less and less on kind of like the nitty gritty of statistics. It's good to like know what a p-value is and what a confidence interval is, and right, how to interpret the results of an A/B test, for example. But at LinkedIn, the job of machine learning engineer is mainly to build systems that use machine learning models to solve some kind of engineering or product problem, right? And so statistics is still probably important, good to know about, right? But you don't necessarily have to be an expert in statistics for this role, at least not to the extent that we expect you to be an expert in machine learning.
Makes sense. And then one of my favorite last questions, how do you define passing the phone screen?
Yeah, that's a good question. Maybe I'll turn it back to you, Ronnie, and let you
Oh
take a
no.
stab at this.
Super hard question. Of course, interviews are sort of a people process. Some things I would also highlight as patterns are having some level of implementation understanding when you're building this out and kind of thinking of how you would scale this up. For example, not just I would use matrix factorization on this portion of the recommender problem, but also I would do so using Spark and kind of this library so it would scale up easily. And then also being able to incorporate domain knowledge and really thinking about the problem and greater context when in that design problem. So that's number two. Number one, I think all the things you mentioned before, having a good concept of what statistical tools we're actually trying to test there, and then how to code it up, as well as have code that you would want to read if you came back to this 3 or 4 years later, which I know sometimes I've come back to my code and been like, oh Lord, what's happening here? So I would say be able to convey those two main topics to the interviewer well as really highlighting kind of your strengths and where you may be able to play an awesome role, and then also conveying that to your recruiter, who's an expert in really finding which team would be best for you and where you would be able to shine. Yeah, and then also I know one thing for me is have questions about maybe specific things you want to work on or that would be interesting to you. Interviews are a two-way conversation, both with, is this a good fit for you? And what are things that you're looking for in your next role? Are things that really highlighted amazing candidates to me. What do you think, Tyler?
Yeah, I think that's a great answer. I think people who ask this question, they want to hear something like, oh, if you can, perfectly code, the answer to a coding question in one extension in under 15 minutes or something, then that's like a guaranteed pass. And I guess the reality is that it doesn't really work that way. There are lots of things that we're trying to evaluate through our technical interview. Right, all of the, you can think about why our interview is designed the way it is and what kinds of things we're trying to evaluate, right? And the reality is that there's never like a hard rule that we can apply to determine whether a particular interview is a passing interview or not, right? So obviously, getting a correct solution to the coding question is good, but it's like not the only thing, right? Coming up with a good design in the data mining product design section is good, but it's hard to be more specific than that, right? So yes, if you think about why the interview is designed the way it is and what kinds of things we're trying to measure and evaluate and gain insight into, you can probably think about, what we're looking for. And the more positive traits that you can demonstrate in the context of the interview, the better. But it's hard to give like a hard rule for what constitutes a passing phone screen.
And maybe actually also one more thing to highlight is I know different from other companies I've worked at LinkedIn, you own your code end to end. When I work with Tyler, when I work with partners, we define the ML algorithms, we define the metrics, and we also implement it in code. We have to make the database schemas. We have to actually write out things to Kafka. There will be no other engineers helping you. You're responsible for that whole end to end, which means that you need to both be a decent ML engineer in terms of ML knowledge, as well as the actual engineering portion of this. You will be writing quite a bit of code. which I found to be different.
Yeah, that's a good point. Okay, cool. So that's all the questions we have about the interview itself. If you have more kind of like questions about the process, the interview process, or questions that are kind of like more in the HR domain, we recommend that you reach out to your recruiter. They're an expert in all of those various topics. But otherwise, I think we'll close out here. So thank you everyone for joining this session. We hope it was useful. And we wish you the best of luck in your actual phone interview.